Hello wonderful, amazing, fantastic algebra students. This is Miss Youngblood here, and in this video I will be going over your Unit 5 test corrections. For those who are still trying to raise their Quarter 3 grades and improve their Quarter 4 grades as well, please keep in mind that all assignments need to be submitted by Monday, June 8th at 11:59 p.m. No assignments will be taken after that. You need to make sure that grades are 100% locked in before the end of the school year. So again, these corrections need to be submitted by Monday, June 8th. That gives you about a week to watch this video and get your corrections knocked out. Remember, when you're completing your corrections, you need to make sure that you are writing the correct answer to whatever problem you're solving and reflecting. Again, if you come to Zoom with me, you will not have to do the reflections. But if you're choosing to watch the video, write the answer as I write it, and then write a reflection, 1 to 2 sentences about the first step or what you think your mistake was. Now, let's get into the corrections. So, for our first problem on the test, we have h of -3 that we're asked to find for the function. This should say h of x equals x squared plus 4x plus 1. So what this function is asking us to do is plug in -3 for the x value and solve for y. So again, -3 is our x value. This is just y. And we're going to plug in that value of -3 into these two x values. So now on your test corrections, you can start writing. So write number 1. We're just going to plug it right in together. Y equals, we're going to change that x to -3 squared plus 4 times, again, changing that x to -3 plus 1. So again, all we did was plug in this -3 for these two x's. So we can type this into our calculator, which I have in front of me. You can also use decimals.com. If you would like the link to that, please send me an email. So I'm going to type in -3 squared plus 4 times -3 plus 1. And if you can see my calculator, it gives us a y value of -2. So when we solve this, we get y equals -2, and we're asked to write our final answers as ordered pairs. So our final answer would be our x value, which was -3, and our y value, which is -2. So again, for your reflection, just go back and remind yourself, how did we start this? What did we do? What was our main process? So that final answer for this one would be B. So again, on your test correction paper, you need to have just this part written down. You do not need to rewrite the problem. As long as you have it numbered and I can see the work, I will know what problem it goes to. Next one is number 2. Number 2 is basically asking the same thing. We're given this number 4 in the parentheses, so that means they're giving our x value, and we're going to plug it into the function. And also keep in mind, this g of x is just another fancy way to say y. So for number 2, on your corrections, you're going to write y equals, write the big 2 that's there, and then we're going to change that x to a 4, and then plus 2 from the function. So again, we just have numbers on the right side of the equal sign, so we can just type that into our calculator. 2 to the fourth power plus 2 gets us 18. So again, all I did was type this into my calculator, and it got me a y value of 18. So our final answer, or ordered pair for this problem, is going to be 4, 18, which is C. So again, this is all you need for numbers 1 and 2. For our next 2 problems, we're pretty much going through the same process. We need to plug in what's in the parentheses for x. So we have the number 0 in our parentheses. So we're going to plug that in for x in this function. And remember, this fancy h of x just means y. So again, we can write y equals 4. We're changing that x to a 0. And then we just rewrite the plus 1. So again, the only thing that's changing is the x value to this number. So when we type that in our calculator, 4 to the 0 plus 1, we get the number 2. So our y value is going to be 2. We need to write our final answer as an ordered pair, x comma y. X is 0, y is 2, so our final answer is C. So again, for number 3, you just need to have here what I have written. And don't forget to write your reflection. Number 4, Same thing, number in the parentheses is 5, so that's our x value. So we're going to plug in our x value for these two x's here. And we're going to change this function notation to just y, because that's what it means. So y equals -2. We're going to put the 5, substitute the 5 for the x value, so -2, 5 squared, plus 16 times 5 minus 33. So that's y equals, and we're going to type this whole thing into our calculator. -2 times 5 squared, messed up my negative sign, plus 16 times 5 minus 33. So that gets us a y value of -3. So our final answer, or our ordered pair for this problem, is going to be the x value, which is 5, comma the y value, which is -3. And that is going to be A. Okay, so that's 3 and 4. Make sure you're doing your reflections. The next set of problems are a little different and might require a little more thought. So we're still given our function notation. So we're asked to find f of x equals 9 for the function f of x equals -2x plus 5. But now if you notice, the number is no longer in the parentheses, it is out of the parentheses. So since we know the x values are always inside of the parentheses, that means that this 9 is going to be our y value for the function. So this 9 is our y value, and remember, f of x is just a very funny way of saying y. So if we have blank equals -2 times blank plus 5, we know the first blank is the y value, and we know the 9 is our y value. So the 9 is actually going to be plugged in here, and this is going to stay x. So now for this problem, we're given the y value and we have to find the x value. In order to do that, we have to solve this equation for x by isolating the variable with inverse operations. So the first thing you want to move to get the x value by itself is the 5, and we're going to move it by subtracting it. Subtracting 5 from both sides, 9 minus 5 gets us 4. 5 minus 5 is 0, so that's canceled, it's gone. So on this side of the equation, we have -2x remaining. So now to get x by itself, we're going to divide both sides by -2. So we get -2 is our x value. And remember, for these 8 problems, your final answer should be written as ordered pairs. The x value we just found was -2, and the y value we plugged in was 9. So our ordered pair is -2, 9, which means our final answer is D. So again, for your reflection, or for your correction, make sure you just have this part, and that you are reflecting on the first step or what you did wrong on your test. Let's switch over to number 6. So number 6 is different from number 5, right? Because the number is now inside of the parentheses. And we know from the first 4 problems that when the number is inside of the parentheses, it's giving you your x value, your input, your independent variable. So the -1 is going to be our x value, through some old vocab words, y'all. -1 is the x value, and this is just function notation, a funny way of saying y. So again, we're going to have blank equals 7 times blank plus 3. And now in this situation, since the -1 is the x value, that's going to be plugged in here for our x value, right? So the x is next to the 7. That means this blank is going to represent the 7, or the x. So we're going to have 7 times -1 plus 3, and this is our y value. So now it looks a little bit more similar to what we were dealing with up here, where we just type this into the calculator to get our actual value. So in our calculator, we're going to do 7 times -1 plus 3, and that gets us -4. So we found that our y value was -4. Our final answer should be written as an ordered pair. The x value that we plugged in was -1. Y value is -4. So our final answer for this one is going to be D as well, which is -1, -4. The last 2 problems on this page are very similar to the 2 we just did. We just have to keep in mind whether or not we're given the x value or y value to plug in. So the 3 is inside of the parentheses. That means it's going to be our x value. H of x is just function notation and a funny way of saying y. So for our equation, we're going to have blank equals negative 3 times blank minus 1. Again, this 3 is the x value, so it's going to be plugged in here for x. So 3 goes here, and y is what we're looking for. Y is what we do not know. So we're going to have y equals, and then this side of the equation we can just type into our calculator. Negative 3 times 3 minus 1, which should get us negative 10. So y equals negative 10. So our final answer for this one is going to be our x value that we plugged in, which is 3, comma, our y value, negative 10, which we see is the letter E. Again, write this down for problem 7. Pause the video if you need to. Number 8, we're now given a number outside of the parentheses, so we know that that's going to be our y value. F of x is just function notation, a funny way of saying y. So for our equation, we're going to have blank equals 5, blank plus 4. Negative 6 is our y value, so it's going to go in this blank that represents the y. So it's going to be negative 6 here, and here we know we're looking for x. So this is, again, going to be more similar to this problem. We actually have to solve for x to figure out what it is. And the way we solve for x is by isolating it with inverse operations. Since this 4 is being added, we're going to do the opposite and subtract 4 from both sides. So we're going to subtract 4 from both sides. On this side, we are left with negative 10. Negative 6 minus 4 is negative 10, equals 5x. Verify that that 5 is positive. Yes. And then 4 minus 4 is 0, so this cancels. Last step is to divide both sides by 5. So we get negative 2 equals x, and our final answer is going to be written as an ordered pair. Our x value, which is negative 2, our y value, which is negative 6. And that means that the answer for this one is going to be B. Negative 2, negative 6. All right, our next pair of problems, we are asked to write the equations in slope-intercept form. So that means you want to write them in the form y equals mx plus b, that is slope-intercept form. And something I do want to mention, if I haven't already, is that you only need to do the problems that you got incorrect. So if you can't remember, if you don't have a picture of your test, I can send that to you so that you're making sure that you're not redoing too many problems. If you're one of the people who didn't get to take the test for whatever reason, then obviously you need to do all the problems because you haven't done any of them yet. But if you have questions about that, feel free to reach out. So again, on this whole next page, writing the equations in slope-intercept form, just a quick reminder, slope-intercept form is y equals mx plus b. That should be your best friend for all of algebra and possibly algebra 2 as well. Y equals mx plus b. That is the slope-intercept form, one of the most basic forms for a linear equation. For these first two problems, 9 and 10, you are literally just given the slope and the y-intercept, and you plug them in for m and b, and write the final equation. So for this problem number 9, the slope is negative 1, so that means our m value is negative 1. Our b value is 4. So your answer is going to be y equals negative 1x plus 4, which we see is A. So that's literally all you need to write for number 9. So you can literally just write the answer. Y equals negative 1x plus 4. But make sure you write some type of reflection. For number 10, same thing. M equals 3/4. B equals 3. So our equation for number 10 is going to be y equals 3/4 x plus 3, which is, which is B. So again, for this problem, all you need to do is write the final answer. But make sure you do that reflection. In these next two problems, again, we're still writing the equation in slope-intercept form. So y equals mx plus b. But now we have to do a little bit more work to find the slope and y-intercept. For our first problem, number 11, we're given 2 points, negative 4, 4, and 0, negative 4. So we need to use the slope formula to find the slope in between them. Reminder, the slope formula is m equals, subtract the y's on the top, so our two y values are going to be 4 and negative 4. So 4 minus negative 4. And on the bottom, we're subtracting the x values. So that's going to be negative 4 and 0. Negative 4 and 0. Be very careful when you're setting up your slope formula. If I start with y1, or the y value in my first point, then I need to start with x1 in the denominator, or the x value in my first point. So these two numbers that are matching vertically should come from the same point. So we see we have negative 4, 4, and 0, negative 4. To get these values, you can type them in your calculator, or you can do them in your head. I'm going to do them in my head because they're a little smaller than the other values you were working with. So 4 minus negative 4 is the same thing as 4 plus 4. So that gets us 8. Negative 4 minus 0 is negative 4. So our slope is going to be negative 2. So we found our slope, and to put our equation in slope-intercept form, we now need to see if we have our y-intercept. And for these first two problems, we actually are given the y-intercept. Between these 2 points, the point that gives you the y-intercept is the x value, is the point that has an x value as 0. And we can see that that's our second point, 0, negative 4. So since this x value is 0, that means that our y-intercept is just going to be negative 4. So we have our slope, m, and our y-intercept, b. So now we're able to write our final answer. Y equals m, which is negative 2, times x, plus b, which is negative 4. So you could have written plus negative 4 or minus 4. So this is our final answer. Y equals negative 2x minus 4, which we can see is A. So again, for your corrections, make sure you have this part written down at least, and make sure you reflected on what our first step was. Looking at number 12, we're going to go through the same process. So start by finding the slope between the 2 points. So we're going to subtract the y values in the top and the x values in the bottom. Subtracting the y values gets us 5 minus negative 1. Again, the y's in the bottom, we're subtracting the x values. So if we start with this 5 for our y value, we have to start with this 0 for our x value. So we're going to do 0 minus 5. Simplifying that, 5 minus negative 1 is the same thing as 5 plus 1, so that's 6. 0 minus 5 is negative 5, which gives us a slope of 6 over negative 5. Our y-intercept is going to be taken from the point that has x, or has 0 as its x value, so that's our first point here. You see the x value is 0, so our y-intercept for this function is going to be 5. Now that we have our slope and y-intercept, we can write our final equation in slope-intercept form. So it's going to be y equals negative 6/5 x plus 5. And we can see that that's ugly. Okay. We can see our final answer, as I was saying, is y equals negative 6/5 x plus 5, and that is D. So again, make sure this is written down for number 12. In this next pair of problems, we are still being asked to write the equation in slope-intercept form for the function that fits these characteristics. So for these next two, we're given the information a little bit differently. So for 13, they just tell us what the slope is, and we're given a point. So the only thing that we're missing is the y-intercept. So we have to use the given point and the slope to work backwards and find our y-intercept. So let's start by noting that we have the slope, so we have our m equals 1. And now we're actually going to use slope-intercept form to find our y-intercept. So remember, slope-intercept form is length equals length, or what I should be saying is y equals mx plus b. And the reason I wrote the b is because we don't have that information, but we're given our slope. So our slope is 1. That's going to go in this first space here, right? Y equals mx plus b. So we have our m. We just need to figure out where our y and x are. You can actually take your y and x from the point that's given to you. So this given point, we're told that our line or our linear function has to contain this point, negative 5, 3. So that means it has to have an x value that's negative 5 and a y value that's negative 3. So you can plug in negative 3 for the y and negative 5 for the x. And now we're going to just solve this equation by getting b by itself. So we're going to start by simplifying the right side with multiplication. 1 times negative 5 gets us negative 5. So that simplifies down to negative 3 equals negative 5 plus b. And now to get b by itself, you want to add 5 to both sides. So we're adding 5 to both sides. And that gets us 2 equals b. So we have our slope of 1 and our y-intercept of b. So our equation is going to be y equals 1x, or x, plus 2. And we can see that that is letter C. So again, make sure you have this written down for 13. 14 is similar, but just involves one extra step. In 13, we were given the slope, and we used a point to find the y-intercept. In 14, we have to find the slope, and then use that slope to find the y-intercept. So we're going to find the slope the exact same way we found it in problems 11 and 12 with the slope formula. So we have m, or our slope, is going to be the difference in our y values. So y minus y, negative 5 minus 4, over the difference in our x values. 2 minus 1. 2 minus 1. Again, the thing that is most important is that you are making sure that if you start with this y value, you have to start with the x value in the same exact point. So negative 5 minus 4 gets us negative 9, and 2 minus 1 gets us 1. So our slope is just this whole number, negative 9. Any number divided by 1 is just itself. So we have our slope, and now we're going to use the same method we used in problem 13 to find the y-intercept. So setting up our slope-intercept form, we have y equals mx plus b, which we do not know. So we just found our slope. Our slope was negative 9. And for our x and y, we can choose either point. I'm going to choose this point because it doesn't have any negatives. So we're going to plug in 4 for the y value and 1 for the x value. And now we're solving. So 4 equals, we can simplify the right side of our equation with multiplication. Negative 9 times 1 is negative 9 plus b. And then to get b by itself, we need to do inverse operations and add the 9 to both sides of the equation. So we get 13 equals b. So we have our y-intercept, 13, our slope, negative 9. So our final equation is going to be y equals negative 9x plus 13, which is b. For the last two problems on this page, again, we're still writing our answer in slope-intercept form, but for these two problems, that process looks a little bit different. So remember, slope-intercept form is y equals mx plus b, and in slope-intercept form, the y variable is by itself. In 15 and 16, the y variable is not by itself. So to put these equations in slope-intercept form, all we have to do is solve for y, which means to get y by itself. So looking at number 15, we have 4x plus y equals 5. Again, so let's go ahead and rewrite that so that we have some space. So on your paper, you do need to rewrite this problem. So 15, you're going to write 4x plus y equals 5. And to isolate y or get y by itself, we want to move this x term. In order to move this whole term, we need to subtract it from both sides. So we're going to do minus 4x on the left side and minus 4x on the right side of the equal sign. On the left side, 4x minus 4x cancels, it's 0. So we have y equals 5 minus 4x. Now you might not see this exact answer, but we can rewrite this as y equals negative 4x plus 5. You can switch the orders of the terms as long as you make sure their signs remain with them. So this negative 4x is still negative when it's moved to the front, and this positive 5 is still positive when it's moved to the back. So our final answer is y equals negative 4x plus 5, which is going to be letter B. Next problem, 16, same process. Start by rewriting it. So rewrite 16, 2x plus 5y equals 30, and we want to get the y variable by itself, just like we did in the previous problem. The first thing you want to move in this problem, very similarly to this one, is the 2x, because we want to move the x term before we mess with this 5. So we're going to subtract 2x from both sides because it is a term that is being, a positive term that is being combined with the 5y. 2x minus 2x cancels to 0, so we can bring down 5y equals, and then something we need to note that I didn't really emphasize here is that we can't combine these, right? So we can't do 30 minus 2x and get 28x because they both don't have an x. So that's the reason here we kept these separate. We can't do 5 minus 4x because they both don't have an x. They're not like terms. So for 16, we have 30 minus 2x. To get y by itself, we need to move this 5. In order to move it, we can move it with division. So when a number is written right next to a variable, that's multiplication. So to get the variable by itself, we need to divide both sides by 5. Dividing both sides by 5 leaves us with y on the left side. And on the right side, we need to make sure that we distribute this division to both terms. So we need to divide this 30 by 5 and this negative 2x by 5. So that gets us y equals 6 minus 2/5 x. So again, you might have to rewrite it like we rewrote problem 15 to see the answer clearly. So we can rewrite that to y equals negative 2/5 x plus 6. So that's going to be our final answer, and we can see that that is letter C. Again, make sure you're writing the corrections all the way out and that you're writing the reflection, at least one sentence about what you did wrong and or how we started the problem. In this portion of the test, we are asked to interpret the domain, range, and whether or not the graphs represent functions. So we're analyzing the domain, range, and whether a graph represents a function. So for number 17, we're asked to find the domain for this graph, which is a circle. As you can see, the circle extends a certain amount left and right on the x-axis and extends a certain amount up and down on the y-axis. The domain is talking about the x values, so we're really going to be looking at how far left and right does this circle extend on the x-axis. So, on your test corrections, for 17, we're talking about the domain, which is focused on the x values. So we can represent the domain using inequalities, and these are the left bound and right bound of the graph. So if we're looking at our circle, we see on the x-axis, it stops here at negative 5. So the circle extends from negative 5 to positive 1. So again, we just looked at how far left and right the graph went on the x-axis. So for your domain, you would write negative 5 is less than x, which is less than negative 1. So again, just write a brief reflection on how we did that. How did we get these numbers left and right on the x-axis? Number 18, we're talking about the range. So the domain talks about the y values, how far left and right the graph is going, while the range represents, domain is the x values. The range represents the y values, so how far down and up the graph goes. So again, we're looking at what y values are included in this circle. So the lowest or the smallest y value that's included is negative 4, because the circle does not go beneath negative 4. So we're going to have negative 4 is the lowest value, is less than y, and then it's going to go up to this value here. This value doesn't have a number, but intuitively we know this has to be 0. So if this is negative 1 and this is positive 1, this number in between has to be 0. So the range or the y values go from negative 4 to 0. So if we look at our multiple choice options, we see that number 18 is going to be D. And number 17 is going to be F. The last question, 19, asks whether or not the graph represents a function. To determine if a graph represents a function, we use the vertical line test. The vertical line test shows us if there is one x value that has two different y values. If that occurs, that means that our graph does not represent a function. So if we look at our x-axis, if we can find one x value that is going to touch this graph 2 times, that means it has two different y values. So let's see. When x is -2, we see this line through -2 touches 1, 2 times. So that means when we plug in -2 into this function for the circle, we could get two different answers. That means it is not going to be a function. So 19 is no. And technically you could say that -2 is one of the numbers that messes you up. You could also have said -3 or -4, but just no will suffice. And we see that that's letter B. 19. So B, or 19 is B. The next set, 20 through 22, same process, same questions, just a different graph. So remember, the domain is looking at the x values, how far left and right the graph goes. So this graph is a little trickier because it has these arrows. When we see these arrows on this shaped graph, which is called a parabola, it's the graph of a quadratic equation, a function, you can extend them. So this arrow means that our graph is going up forever, and it's also going to the left forever. Well, this arrow also means it's going up forever and to the right forever. So our graph is finite, but these functions, our coordinate plane, I should say, is finite, but our graphs that represent them are infinite. They can go on forever and ever. And these arrows just kind of represent that idea, as well as these on the coordinate plane. So for the domain, this arrow going to the left forever means that the lower bound for the domain, or the first value, is -infinity. And this arrow going to the right forever means positive infinity. So that just means there's no limit on what x can be. It can go to the left, right, it can go all the way to -5,072,000. There will be some y value that this graph will have. So there's no restrictions on the domain. 21 is the range, which is again talking about the y values. So same thing. We're looking how far down it goes on the y-axis. So we see it does not go beneath -3. And how far up it goes. So just like with the domain, the range goes up forever. So when it's going up toward the positives forever, that means the upper bound will be infinity, and the lower bound, like we said, is going to be -3. So domain is left and right forever because of the arrows. The range -3 to infinity because it does not go beneath -3, but it goes up forever. Last question for this set, is it a function? So remember, if a graph is a function, that means that every x value only has one y value. So we can just do a quick check. -5, one y value. -4, one y value. -3, 1, -2, 1. So we can see this graph is going to be a function because every x value only has one y value. Also, if you do the vertical line test, there is no place we can draw a vertical line where it's going to hit the graph 2 times. If that did occur, that would mean that this is not a function. So yes, it's a function. You want to make sure you include your letters. So 21 is going to be E. 20 is going to be C, and 22 is going to be A. Again, make sure you have this work written down here. You don't need to sketch the graphs, but also make sure you've done at least a 1-sentence reflection on your mistake when you did the test or our first steps in solving these problems. In this next section of the test, we are asked to evaluate a function from a graph. So it's similar to the first page, but instead of giving an equation to plug in x for, we're given a graph and we have to interpret it interpret the values based on the pictures. Sounds complicated, but it's actually not that bad. Okay, so problem 23 is asking us to find the y value for f of negative 2. So remember, when a number is written in the parentheses, that's giving the x value. So this whole thing represents the y value. So basically, we're just looking for this point on the line. So when x is negative 2, the y value that is on the line, we have to go up to find that to hit our blue line here. So it's going to be 1. So when x is negative 2, we go up to the graph 1 to get the y value. So 23 is 1. So what I want you to write for these problems is just this part. I do want you to write what the original problem was. You don't have to draw the graph, but write 23 f of negative 2 equals 1. Number 24, we're doing the same thing. So we're going to go to 2 on the x-axis, but to now get to our graph, we have to go down to negative 5. So when x is 2, the y value is negative 5. So for 24, you should have negative 5. Let's make sure we have these letters. 23 should be B. 24 should be B. Our next function, we're doing the same thing. H of 2. When x is 2, we have to go up to hit our graph, and we go up to 4. So h of 2 is 4, which is the letter A. When h is 5, or when x is 5, excuse me, x is 5, we have to go down to our graph to negative 2. So h of 5 is going to be negative 2. So that answer will be C. For this next set of problems, we are asked to determine whether or not the ordered pairs represent a linear, quadratic, or exponential function. In order to determine that, we have to look at how the y values are changing. So I've already went ahead and organized the ordered pairs for you from least to greatest, so you don't have to worry about that step. But now we're just going to look at this column, the y values, and look at how they're increasing or decreasing and see what patterns we notice. And that will tell us whether the function is linear, quadratic, or exponential. So for 27, we see that these numbers are increasing, and we want to look at each increase individually. So from 1 to 3, we are adding 2. From 3 to 7, we are adding 4. And from 7 to 15, we are adding 8. So this change is not the same. Because this change is not the same, we automatically know that these ordered pairs, or these points, do not represent a linear function. Now we need to see this second change, if it's increasing additively with addition or multiplicatively with multiplication. That will determine whether or not these ordered pairs are quadratic or exponential. So from 2 to 4 and 4 to 8, those aren't increasing by the same amount additively, right? 2 plus 2 is 4, but 4 plus 2 does not get me 8. These numbers are increasing multiplicatively. 2 times 2 is 4, and 4 times 2 is 8. So because this second change is with multiplication, we know that these ordered pairs have to represent an exponential function. So we're just going to write exponential, and our answer would be C. So to show your work for this on your test corrections, rewrite the ordered pairs, show me their changes, write the final answer, and for your reflection, tell me how we know it's exponential. Number 28, we see these are also increasing. So 1 plus 5 gets us 6. 6 plus 7 gets us 13. 13 plus 9 gets us 22. Again, we see that these numbers aren't exactly the same in the first change, so it's automatically not linear. In order for us to prove that it's quadratic, we have to look at the second change. For the second change, we see that these numbers are increasing with addition. 5 plus 2 is 7. 7 plus 2 is 9. So since the second change is constant and with addition, we know that these ordered pairs have to represent a quadratic function. So for 28, make sure you write the ordered pairs, show the change, tell me it's quadratic, and then in your reflection, make sure you explain why. And lastly, number 29. So 29 is a little bit different because these numbers are actually decreasing. So we have to use subtraction to go from the different y values. 15 minus 4 is 11. 11 minus 4 is 7. 7 minus 4 is 3. So these numbers are changing, or these y values are changing at a constant rate. These numbers are the same. So because they're the same, we don't need to look at their second change, and we can automatically see that these ordered pairs represent a linear function. So that would be A. Again, for this section, make sure you do write out the ordered pairs and show their change, in addition to identifying the function and reflecting on how you know that that is the correct function. We have finally made it to the last page of the test. So for these two problems, we are, well, let's focus on them one at a time because they're actually not that similar. For this problem 30, we are identifying the domain, the range, representing the ordered pairs with a map, and determining whether or not it's a function. So it's very similar to what we did with the graph. We're just using specific ordered pairs instead. So on the previous page, I can't remember what specific problem it was, but we were talking about the domain, and most of you will remember that the domain is the x values. So domain is x values. And we know in the ordered pairs, the first numbers are the x values. So our domain is just going to be us listing the first numbers of the ordered pairs. So the domain is going to be 1, 0, and 2. Those are the three numbers in the domain because those are the three x values that are represented in these ordered pairs. We technically don't need to write 1 2 times because it's already represented there. Similarly, the range represents the y values. To identify the y values, we're going to write the second numbers in the ordered pairs. So that would be 2, 3, and 4. Again, 2 appears twice, but we don't need to represent it 2 times in the domain. To create our map, we're going to list our domain, 1, 0, 2, and our range, 2, 3, 4. Again, the left side was our domain, right side is the range. To represent our ordered pairs in this map, we're going to draw lines from the corresponding x and y values. This first ordered pair says that when x is equal to 1, y is equal to 2. To show that, we're going to draw a line from 1 to 2. That's the first ordered pair. The second ordered pair says when an x is equal to 0, y is equal to 3. To show that, we're going to draw another line from 0 to 3. Third one, x is 2, y is 2. We need to draw a line from 2 to 2. And the last one, when x is 1, y is 4. Draw a line from 1 to 4. So this would be how you would represent this relation of ordered pairs as a map. Last question is whether or not it's a function. Remember, a relation is a function if every x value only has one y value. So that means if I plug in any x value into the function or into whatever rule we have, there's only one possibility that will come out. So if we look at our domain, we want to see if any of these x values go to 2 different y values. We see the number 1 goes to 2 different y values, 4 and 2. So this is not going to be a function because of this x value 1. So we're going to say no because of the number 1. For this reflection, you don't need to write out the ordered pairs, at least have all of this written down. So what's the domain, what's the range, draw the map, and then you can just write no 1 and I'll know what it means. So everything that I've written, I need you to write for number 30. 31, we're working with the idea of using functions to represent problems in the real world. So for this specific problem, it says let M of H represent the money you earn after working for H hours. We're asked to interpret the independent variable, dependent variable, and what this means in terms of these given variables. So the independent variable is what we're plugging into the function. The independent variable is usually x, so it's our values in the domain. So the way this is set up, we see we have M of H. Thinking back to the very first page, the number that was inside of the parentheses was always our x value, our independent, our input, what we control. So our independent variable is going to be whatever this H is. And if we continue reading the sentence, it says that H is the hours you worked for. So the independent variable is going to be hours, while the dependent variable is going to be the other variable that's represented in the function, the M, which they said represents the money you earned. So dependent can just say money. So this equation, M of 4 equals 68, the 4 is inside of the parentheses, so it's the hours, and the 68 is what the function is equal to, so that's the money. So this is saying earn $68 after 4 hours. For your reflection for this one, just make sure you include briefly how we know the independent variable is the hours and the dependent variable is the money. This kind of explains itself, but how do we know with the way these are written that this is the hours and this is the money? And additionally, you need to also be reflecting on this one. 2 more problems. In this next set of problems, we are asked to graph given functions by plugging in given x values and representing that on the coordinate plane by plotting points. So let's finish strong. Our first function is going to be a quadratic function. The easiest way we've learned how to graph functions in class is by creating a table of values. So in our first column, we put the x values, which I gave to you. So we're using -3, -2, -1, 0. In the middle column, we put the actual function. So our given function is here. X squared plus 4x plus 8. And the last column is what number we're getting out, which is going to be our y value. So we'll plug in our x into the function, get the y value, and then graph those points over here. So for our first row, we're going to plug in this -3 in for both of these x's. So we would have -3 squared plus 4 times -3 plus 8. We'll plug them all into the calculator after the fact. Let's get our equations written first. For the second one, we're going to change those x's or -3's to -2's. So we're going to have -2 squared plus 4 times -2 plus 8. Third row, change them to -1. -1 squared plus 4 -1 plus 8. Last row, we're plugging in the zeros. 0 squared plus 4 times 0 plus 8. Now we're going to type these into our calculator to get the y values. -3 squared plus 4 times -3 plus 8. It says 5. Just going to change those -3's to -2's. Changing them to negative 2's gets me 4. Changing those negative 2's to negative 1's gets us 5 again. And changing those negative 1's to 0's gets us 8. So now we're going to plot these points to actually see what the graph of our function looks like. Our first ordered pair is negative 3, positive 5. So that means we're going to go to negative 3 on the x-axis and then go up to 5 and put a point there. That represents our first ordered pair. Something I notice on a lot of tests is people would draw lines to connect to this point. Don't draw lines, just count over, lift up your pencil, and plot the point. Again, for your corrections, you only need this table. You do not have to actually plot the points. In your reflection, make sure you're telling me what we did here, how did we get this table, and tell me how did we at least plot the first point. So negative 3 to 5, negative 2 is going to go up to 4, negative 1 is going to go up to 5 as well, and 0 goes up to 8. Something that we actually learned during distance learning is that these graphs are symmetric. So this is the middle point, which means these points have to be symmetric, so the same distance, like a mirror reflection of each other. A reflection, that's kind of what I meant to say, thinking about geometry. So if this point is 0, 8, this next point, negative 4, also has to go up to 8, and that just maintains the symmetry. So our graph is going to look something like that. Again, you don't need the graph. Create the table. For your reflection, tell us how we filled it in. The last problem for this test, we're graphing an exponential function. So we're going to create our table, put our function in the middle, and find our y values. The x values you're given are 0, 1, and 2. Again, we're just plugging in these x values in for this x. Everything else stays the same. So we're going to have 3 to the 0 power plus 2. In the next row, we're going to have 3 to the first power plus 2. In the last row, we're going to have 3 to the second power plus 2. Now we can type these into our calculator to see what y values we're going to get. 3 to the 0 plus 2 gets us 3. So our x value is going, or our y value is going to be 3. Changing that 0 to a 1, 3 to the first power plus 2 gets us 5. So our next point is going to be 1, 5. And our last point, changing that 1 to a 2, 3 to the second power plus 2 gets us 11. So our last point is going to be 2, 11. And now we need to graph those points. This first point, 0, 3, 0 on the x value, go up 3. So this first point is here. Second point, 1, 5, go to 1 on the x-axis and go up to 5. This point here. And our third point is 2, 11, go to 2 on the x-axis and go up to 11. And those 3 points represent our exponential function. Now, similar to the quadratic function, exponential functions also have key features that we didn't really have time to learn about. But when you're drawing your graph, this number tells you where your exponential function is going to slope off to. So our graph is going to look something like this. Again, for those who actually took the test, I wasn't too picky about that. I just wanted to make sure you guys understood that those 3 points that you plotted should have been connected. And I believe that's our last question for the test. Yes. So if you made it to the end of this video, that means that you have finished your test corrections. Congratulations. If you have not already, please go back and do your reflections. So I've recorded this video. you hear me talking you through how to do the problems, just write a brief reflection, 1 to 2 sentences about what your first step was for each problem, or what your mistake was if you actually have a copy of your actual test. If you still have questions about the reflections, feel free to reach out to me and I can help you with that process. Also, if you're still confused, again, you can reach out to me and we can do Zoom, we can talk through text, email, whatever you need to get these corrections completed, submitted, so that you can improve your quarter 3 grade. I thank you so much for taking the time to watch this long video. If you have any other questions, please feel free to reach out. And yeah, miss you guys, and I look forward to seeing or hearing from you soon. Bye.